In this video, I want to talk a little bit more about welding. This is an introduction to welding. So, the skills of welding, cutting, and brazing are an essential part of anything you do with metal, which is metal fabrication. Metal fabrication is building, shaping, and assembly of a product, equipment, or machine from raw stock. Metal fabrication can be done using rivet, bolts, welding, and so on and so forth. A metal fabrication is primarily assembled using one or more of the following process. You use welding, you use thermal cutting, and you use brazing. Welding is used extensively in many areas of industry: automobiles, home appliances, construction equipment, furnaces, and air conditioners. The process of metal fabrication can be divided into several, often distinct steps. First, you have layout. This is the process of drawing lines on the raw material stock according to parts drawings and specifications. Then you have cutout, the process of removing all the unwanted material around the laid out parts, sometimes just cutting the material to the desired length. Some common ways to do this are flame cutting, plasma cutting, sawing, and punching. And then finally, we have assembly, the process of placing all the parts together in the correct location and orientation with each other. The parts may also be held in place with small welds called tack welds. Then we weld. This is the process of permanently attaching the parts together to form the finished part. And then finishing can be accomplished by a number of different processes such as grinding, drilling, polishing, painting, and more, so on. Many people think of welding as either a gas torch or an electric arc welding process. Many also think it's just melting two pieces of metal together. The American Welding Society defines it as a localized coalescence of metals or nonmetals produced by either heating the materials to the required welding temperature with or without the application of pressure, or by the application of pressure alone with or without the use of filler material. The term coalescent means the fusion or growing together of the grain structure of the material being welded. The terms metal and non-metal are also used because plastics and ceramics are not metals, but they can still be welded. The phrase with or without application of pressure is important because without the application of significant pressure, some of the process would not work, such as electric resistance welding and friction welding. Welding processes greatly differ in the manner in which heat, pressure, or both is applied to the equipment being used. There's some 67 different welding processes requiring hammering, pressing, or rolling to affect the coalescence of the weld joint. Other methods bring the metal to a fluid state and the edges flow together. The most popular welding processes are gas metal arc welding, flux core arc welding, shielded metal arc welding, gas tungsten arc welding, oxyacetylene welding, torch or oxyfuel brazing. The two most popular thermal cutting processes are oxyacetylene cutting or plasma arc cutting. Gas metal arc welding uses a solid electrode wire that is continuously fed from a spool through the welding cable assembly and out through the gun. A shielding gas flows through a separate tube in the cable assembly out of the welding gun nozzle and allowed around the electrode wire. The welding power is transferred to the electrode wire at the welding gun, where the arc melts the continuously fed filler electrode wire and the surface of the base material. This type of welding is fast and economical because it can produce long welds rapidly that require very little post-weld cleanup. So again, this is an example of a gas or metal arc welding. Okay, we have a spool of low pressure wire, goes right through the torch tip, okay, and goes down and is with the electrodes, okay, and it actually melts that wire, okay, into the arc. Flux core arc welding is another process that uses a flux core electrode wire that's continuously fed from a spool through the welding cable assembly and out through the gun. Welding power flows through the cable assembly. The welding current melts both the filler wire and the base metal. Gas metal arc and flux core arc welding are very different welding processes but use similar equipment. Both of these processes are classified as semi-automatic process because the filler material is automatically fed into the welding joint, and the welder manually moves the welding gun along the joint. Shielded metal arc welding uses a 14-inch long consumable stick electrodes that both conducts the welding current from the electrode holder to the work. And as the arc melts the end of the electrode, it becomes part of the weld material. The equipment used in this process is very basic compared to the other processes. So again, you have a shielded metal. The electrode arc is created between the covered electrode and the base metal. This heat of that arc melts the electrode and the base metal where the arc contacts it. The metal from the electrodes provides the filler material. The equipment consists of a welding transformer and 2 welding cables with a work clamp and electrode holder. So the work is actually part of the circuit. Gas tungsten arc welding uses a non-consumable electrode made of tungsten. During this process, the arc between the electrode and the base metal melts the base metal, and the end of the filler metal is manually dipped into the melted weld pool. This type of welding is the cleanest of all the manual welding process because there's no flux needed to clean the weld in gas tungsten arc welding. So again, we use a filler rod, we have our power, we have a shielding gas, and the filler rod is held into the pool. Oxyacetylene and oxyfuel brazing can be done with the same equipment. Oxyacetylene welding is a high temperature flame that's produced at the torch tip by burning oxygen and fuel gas. The most common fuel is acetylene. Oxyfuel gas cutting and plasma cutting are the 2 most commonly used for thermal cutting. Air carbon arc cutting is also used frequently, as well as laser beam cutting. Oxyfuel gas cutting is the process that uses high temperature flame to heat the surface of a piece of steel to the point where a forceful stream of oxygen flowing out through the center hole in the tip causes the hot steel to burn away. This process relies on rapid oxidization of the base metal at elevated temperatures to make a cut, and can be used on metals that are several feet thick. So again, I can actually use a welding torch, oxygen valve, fuel hose, and it has 2 cylinders, one for the fuel gas and one for the oxygen. And it gives me a very hot flame that I can actually melt through material and cut out patterns and everything else out of materials. Plasma arc cutting uses a stiff, highly ionized, extremely hot column of gas to almost instantly vaporize the metal being cut. Plasma cutting equipment consists of a transformer, plasma torch and cable, work clamp and cable, and air supply. So depending on the different materials, depending on what you're looking to accomplish, the type of welding needs to be decided on. Most often in HVAC, we are using oxyacetylene. Okay, and we're using that for cutting, brazing, and sometimes welding.